All right, so this first example that we're going to look at, example number 3 on our notes, this is a one-sided t-test that we'll be using given statistics. So it is reported that female field crickets are attracted to males that have high chirp rates, and it is hypothesized that the chirp rate is related to protein intake. The average male chirp rate is reported at 58 chirps per second. A sample of 40 male crickets was fed a high-protein diet, and their mean chirp rate was observed to be 95 chirps per second. Is this convincing evidence that a high-protein diet increases chirp rates greater than 58 with a significance level of alpha equals 0.005? The sample standard deviation is 35. So we will use our 4-step method. First, state, and we wish to perform a t-test to determine if we have convincing evidence that a high protein diet increases chirp rates greater than 58. So the mean is the chirp rate in chirps per second. And our null hypothesis is 58 chirps per second. And our alternate hypothesis is that mu is greater than 58 chirps per second. Our plan is, if the conditions are met, we will perform a one-sample t-test with 39 degrees of freedom. And 39 comes from the fact that we have a sample of 40 male crickets. Okay, so we need to do, in order to do our test statistic, we need to first do our check our conditions. So, is it normal? Well, n is equals 40, and the CLT says sampling distribution is approximately normal. For n greater than or equal to 30. So that is fine. Is it random? No information was provided. Okay, so we will be cautious in generalizing our results to the greater population. Independence. This is sampling without replacement. So we'll have to check our 1/10. It is reasonable to assume there are more than 400 crickets in the population. So therefore the 10% rule is satisfied. Okay, so that's state plan 2. So our test statistic is t equals x bar minus mu over sx divided by the square root of n. So x bar from our data was 95. The mean is 58. Sx is 35. And n was 40. And when we work that out, we get 6.69. Now we need to use that to find our p-value. So if we sketch this out, 6.69 being there, we want to find the area in this section for 0 there. And so we can do TCDF, lower, upper, and degrees of freedom. So you're going to enter TCDF, 6.69, E99, and 39. And what you'll get then is the p-value of 2.86 times 10 to the minus 8. And so that would be moving our decimal place 8 times from where between the 2 and the 8, so 1, and I'm going to add 7 decimal spaces. So that's the equivalent. So finally, to conclude, we are using a significance level of 0.005, and so we want to, remember, if the p-value is less than alpha, we would reject. Okay, so since p-value is less than alpha, reject. So that's what we're thinking. So what we're going to write, however, our conclusion, with a p-value less than alpha equals 0.005, we reject the null hypothesis and conclude there is evidence that the high protein diet the high protein diet for crickets in our sample results in a chirp rate greater than 58 chirps per second. All right, so we could alternatively do a t-test on the calculator. So let's pull up our calculator. Okay, so we're doing a t-test. We'll choose stats. We'll enter 58 for our null hypothesis. X bar is 95, Sx 35, N is 40, and our alternative hypothesis is greater than the null hypothesis, and we will calculate first. And so we get mu is greater than 58, t is 6.685 or 6.69 as we had, p value is 2.8999 to the negative times 10 to the negative 8. So this matches what we had. We can also do the same test, and this time draw. And so when we draw, this is what we end up with. The 6.68 is small, so we can't see it showing up clearly, but it does show the graph with the value here.